I want to go eat. That's what I want to do. I want to go to eat. Skip those. Just skip those.
All right, starting off here.
He says yes.
Last section of chapter 1 is going to deal with algebraic expressions. Chapter 1 is kind of like the basics of everything that we do. We've talked about properties, order of operations, just a lot of the basic things that we're going to be using throughout the entire semester. Today is talking about what makes up an algebraic expression, and we're going to look at it a couple different ways. Like in some cases, they're going to like write out in words an algebraic expression, like maybe x increased by 2, and then we have to write it out as an actual expression, or we might do it the other direction. Might do it vice versa, where they give us the expression and we have to express it in words. So first of all, we're going to see a lot of keywords or kind of buzzwords when we talk about the operations. And so we need to know what some of those buzzwords are going to be. These are all words that we've seen or heard before. We're going to go through the 4 operations here. And the first one is addition, or to add. And if I were to add 2 things together, 2 numbers, 2 variables, whatever, what are some words that we might hear or say? Plus, yep. What is the answer to an addition problem? Sum. Okay, that's a big one. More than. Okay, I might say I have 2 more pencils than my neighbor or my partner, which means however many they have, I have 2 more than that. Or increased by. Okay, so all of those talk about adding 2 things together. And then obviously subtraction is going to be kind of just the opposite of some of those. Minus is the word we see a lot of times. The answer to a subtraction problem? Difference. Good. Instead of more than, be less than. And I will tell you this, and we'll look at some examples with this, but sometimes when people see the words less than, they think, oh, it's the less than symbol, like the less than or inequality symbol, but it's not. I always thought it was the projector, but it's this new light, that's blinking off and on. It's weird because it only does it like first hour. It doesn't do it like the rest of the day. Okay, and then the opposite of increased by is decreased by. Okay, the other 2 operations. Multiplication. The answer to a multiplication problem. What word do we use? Do I remember that one? Addition is sum, subtraction is difference, multiplication, product. Yep. The product of 2 numbers means we're multiplying those 2 numbers together. Okay, we might see just the real basic word times. And then a more specific way of multiplying by 2 is if I wanted to double something, then I might take twice or multiply it by 2. Okay, the 4th operation is division. The answer to a division problem.
Anybody remember that one? Quotient, yep. Another word that sometimes we see that's associated with division is like a ratio. A ratio of 1 to 2 means I write 1 over 2 and write it as a fraction. So division or a fraction can sometimes be considered the same thing, depending on how we're using that. Okay. We talked about exponents earlier in the chapter, and we evaluated exponents, and we did some different things with them. But if we're looking at like some different words, when we talk about exponents, we'll typically see the word power. 3 raised to the 4th power. And you could do it with any exponent. But then we have some special ones like squared. Squared means I have an exponent of 2. Cubed means I have an exponent of 3. So those are just specific types of exponents. Rather than saying 2 to the power of 3, I could just say 2 cubed, which is the same thing. Okay, we also talked about roots earlier in the chapter, but there's not much really that we need to talk about with roots, I don't think, because it'll say the 4th root of 16 or the 3rd root of 8. And so really the word root is the word that we're going to see whenever we're trying to do a radical question. And there's not really a whole lot of, maybe like a square root, which is the opposite of squaring something, or a cube root, but they're still roots. And so there's not much there to talk about. All right, so the first thing we're going to talk about today is what we call a verbal expression. Okay, a verbal expression is the way that we would say or read an expression. So if I had an expression written down and we had to say what does that expression represent or mean, then how would we say it? And what we're going to do is we're going to write it out. So what I'm going to do first of all is I'm going to give you some verbal expressions, and then we're going to write the algebraic expression that represents it. Okay? And then we'll do some that maybe go the opposite direction as well. So the first one, 4 more than 3 times the number. And just like you would with anything, we're going to basically read it from left to right. Okay? As we go through it, we're going to try to replace everything with some type of operation and write it as an expression. So 4 more than means plus. 3 times a number. And so what would I put in for that number? X, because we don't know what that is. Okay. So 4 plus 3x. Would it be okay if I wrote 3x plus 4? Are those two the same thing? They would be, okay? Sometimes they can be switched around, and we could use the commutative property on them. The only reason why we can do the commutative property here is because we have a plus sign here, okay? And so we can flip-flop. If this was a minus sign or a division sign, then no, we wouldn't be able to do that, okay? It also doesn't matter what variable you use. Unless it says in the expression we're going to use x, 3 times the number x, then I would want to use x. But if it doesn't state what the variable is that we're using, then you could use any variable in the alphabet, and it would be okay. All right, 6 less than the square of a number. Okay, this one, you got to be kind of careful on this one. With more than, we said addition can be flip-flopped. But when we have less than, we know less than means minus. But what we have to decide, where do we want the 6 at? Okay? Because if we think about something here, and I guess I can just write it on here. If I were to write, in this case here, 6 less than the square of a number, the square of a number would be like n squared or x squared or whatever variable you want to use, okay? And if I take 6 less than that or 6 away from that, then it would be minus 6. Okay? But in this situation, you could not put the 6 first. And it's a little bit tricky because it's written first, right? And so most people's inclination is 6 minus n squared, but that is not the same thing. And so with addition, you can flip-flop it, but with subtraction or division, you got to be really careful of the order that they go in, and you got to think about which one makes more sense. Two minus 6 and 6 minus 2, I don't get the same result, right? And we talked about that with commutative property earlier in the chapter, is those two are not interchangeable because it's subtraction. So if I had 6 less than something, let's say I have $20 and I said that you have 6 less than I do, okay? Then how much money do you have? What would we do? We'd have 14. What do we have to do? Where did the 6 come in? Did we do 6 minus 20 or did we do 20 minus 6? 20 minus 6. Otherwise we would have got a negative, right? And so we're subtracting 6 from whatever the expression is. And so that's why okay, another example of a verbal expression, and we've seen ones like this before as well, is what we call a verbal formula. Okay? If I wanted to ask you what the formula is for, some of the figures maybe we did in geometry, a triangle or a rectangle or a trapezoid, we could express that in words, right? Typically we don't. Typically we express it with variables that represent like A for area, B for base, H for height, L for length, W for width, things like that. And so we try to use variables that represent something specific when we do a formula. So on this one here, we're going to talk about the area of a triangle. The area of a triangle area of a triangle is 1/2 the product of base B and height H. And we've seen the area triangle formula before, okay? It's not something new to us. It's maybe been a while, but we've done it before. So we're going to start off with A representing the area, okay? Whenever I see the word is means equals, right? Area equals. And then we're going to go 1/2 the product of the base and the height. Okay, and you might have seen this different ways, like when you did triangles way back when, sometimes maybe your teacher taught you base times height divided by 2, which is the same thing. And we could rewrite that as a verbal expression. We could say the base times the base and the height divided by 2, okay? And so there's other ways that you could write this and express the formula, but in this case, based on the verbal expression that we're given, this would be the algebraic expression that we're looking at, okay? So we're just trying to get something to represent. And here we are specific about the variables that we're using, right? We are trying to use B for base, H for height. Because we're talking about a specific triangle, then I'm not just randomly choosing X or N for my variables, because we want it to represent something specific, okay? All right, a couple of other things in this lesson, and there's kind of a mixture of some different things that we're going to talk about here. We've seen this word quite a bit as we've gone through this first chapter. And whenever I see this word evaluate, it's really just telling me to simplify, okay? Make this an equivalent expression, or simplify it in some shape or form, apply the operations or whatever exponents or things that we have. We did this especially like when we did order of operations a lot, right? And I gave you like some of those big long ones, and we had to break it down into smaller parts and kind of go through the order of operations. It's going to look a little bit different today because I'm going to give you an expression, and it may not even be written as an equation today. I have 4x squared over x minus 6. And when it says to evaluate, we're going to evaluate it for different values. Okay? So you might do a couple of parts on something like this. If I tell you that x equals -3, then that means we're going to take -3, and where we're going to put it? In for x, okay? And what we notice is, how many x's do we got in the expression? Got a couple of them, right? So wherever there's an x, we have to put a -3 into it. And so probably the best thing to do here would be to write it out. And I think it's really, you got to be really careful about how you write this out sometimes. Especially with like an exponent of squaring something or whatever it might be. Because what we had talked about, if I don't put parentheses around that -3, that's an entirely different problem. And your calculator is going to treat it as an entirely different problem. And this right here, the 3 is going to be the only thing that's getting squared. The negative is kind of out there on its own. Okay, it's not attached to the 3. Here, the negative is attached to the 3 because it's all together. We're squaring the whole thing. So this one's really -3 times -3. And that's what my x value is. So this is the one that we want right here, not this one here. So just make sure you're aware of that. Especially know how to put this into your calculator, because that's really the big thing, is how do we put this in, okay? All right, so now let's simplify it. Now we're going back to the order of operations, which we did earlier. What would be step 1? Square the -3, exponents, right? So we're going to go 4 times 9. Okay, parentheses first. We don't have any exponents, okay, left. So now we're going down multiplication and division from left to right. Well, there's only one multiplication problem here, which is 36 on top. -3 minus 6 is -9. And we finish evaluating it, and we get -4. Okay, now, here's what's going to happen sometimes when we do these evaluation problems. Let's plug in x equals 6. So we're still using the same expression, but now we're plugging in a number for x, a different number, just like we did on part A. So the first step always is, let's go ahead and plug it in. So this would be 4 times 6 squared over 6 minus 6. Okay, we kind of saw this the other day when we did order of operations. We talked about what happens here. And what's going to happen here is we've got 4 times 36 Okay, 4 times 36 would be 144. And then on bottom, we have 0. Well, what happens when we have 0 on bottom? no solution, can't do it, okay? This is undefined. Okay? If you try putting that into your calculator would tell you the same, right? It would say, oh wait, hey, you can't do that. It's going to give you an error message of some shape or form. All calculators are going to say something a little bit different, but it's going to give you an error message. Can't do it, okay? So even if you try putting that into your calculator, make sure you remember the difference between 0 being on bottom versus 0 being on top, because those are two completely different things. If 0 is on top, then it would be 0, okay? But if 0 is on bottom, not the case. Okay, I'm going to give you a couple of expressions. And if I simply just ask you the question, we're not going to necessarily plug anything in here, but if I just ask you the question, what value makes this function or expression undefined? What can we not put in for y? 0, right? Y cannot be 0 because I cannot put 0 in right here. There's no addition or subtraction attached to it, so y cannot be 0. And the way that we would write that is y cannot equal 0. That would be the one value that is undefined, or y cannot be. If I gave you one like this, x plus 2 over x plus 8. What value of x will not work? Negative 8. How come? It makes 0 on bottom, right? So all you would really need to do is set the denominator equal to 0. A lot of us can probably determine that in our head because negative 8 plus 8 are opposites, so they make 0, right? But you could just set it equal to 0. I would say x plus 8 cannot equal 0. So if I subtracted 8, x cannot equal negative 8. It's okay to have 0 on top. So I don't have to do anything with the x plus 2. Okay, there's nothing wrong with that. The x plus 8 on bottom is the one that causes issues. Okay, so it's really just the denominator that we got to pay attention to when we do this. We talked about the distributive property earlier in the chapter. We're going to look at some examples of the distributive property here where we can use it. When we did it earlier in the chapter, we were just really doing it with all numbers. We didn't really have any variables that we were doing it with. But this is a skill that you guys have done a lot, all the way back to Algebra 1, maybe even before. We're taking the 3 and we're distributing it to anything that's on the inside. We're taking 3 times x, we're taking 3 times 4. I rewrite my expression as 3x plus 12. Is it okay for me to combine 3x and 12 together? No. Okay, they have to be alike. One's got an x, one does not have an x. They cannot be combined. That's my answer. That's all we have to do. If we had a negative out in front, or let's do it this way. This one, we don't see this way very often, but sometimes and maybe I should put this in parentheses so we know that we're multiplying by negative 4. It's not a minus 4 at the end. So I'm going to take negative 4. Sometimes the number might be after the expression, okay? Most of the time it's in front. Every once in a while we might see it at the end. So here we're going to take negative 4. And we're going to distribute it. So negative 24 plus 20y. And that would be our answer. Okay. Would it be okay if I wrote (20y minus 24, or would I count that wrong on the test? What do you guys think? Would this be okay? How many people think, yeah, go for it. It's good deal, right? No, nobody wants to do that? Everybody thinks it's bad news? It's okay, right? It's okay, because all we did, what's between these two? It's just a plus sign, right? And when there's a plus sign in between, can we flip-flop it? You guys want to change your answer now? Right? It's okay. And I tell you that because sometimes people want to put the variable in front, okay? Because that's kind of the way we're used to seeing it. Okay? And you might say, well, now we have a minus sign in between. Well, we do, because that minus sign has to stay with the 24. Okay? As long as that minus sign stays with the 24, then we're okay. So those two are exactly the same thing, and it would be okay. Okay? So I'm just showing you that there's more than one way to write some of these answers out, and there's nothing wrong with that. Okay, a couple of more vocab words. A term. A term Term is a number or product of a number and one or more variables. Okay, so if we looked at some examples, 8 is just a number. We would refer to that as a term. Okay, most of the time we would refer to it as a number, but it would still be a term. It could be a variable all by itself. If there's no number in front of x, what's the numbers assumed to be there? 1. Okay, so there's still a number being multiplied by it, but we just don't usually write the 1. Okay, I could do 6 ABC. Taking a number times one or more variables. So here we happen to have 3 variables. Kind of like the formula that we did where we had base and height, and we're multiplying 1/2 times base times height. That would be an example of a term. But it's one term, okay? It's one term because we don't have any addition or subtraction here. And so you might add that to your definition, that you cannot do any addition or subtraction. Multiplication is the only, and it would be okay to have division here too. Because y divided by 2 would really be the same thing as taking 1/2 times y. Those two are equivalent to one another. So one way you could think of it as multiplication, another way you could think of it as division, but it's saying the same thing. Neither one of those are necessarily better than the other. It's just a couple different ways of writing it. Okay, but still no addition or subtraction can be included. Okay, the next one is the word coefficient. When we talk about a coefficient, what are we talking about? How would you guys explain a coefficient to me? I know we've heard of the word before. Anybody want to take a stab at it? Have you guys all heard the word coefficient before? Okay, it's not a new term. So we've seen it. How would you explain or describe a coefficient? Therefore, what is a coefficient? Would be a good question. No takers? Majan, coefficient?
I have no clue.
No clue? Shane?
It's a number.
Okay. What's special about that number?
It's positive.
Could be, doesn't have to be.
I can divide by something.
Not necessarily. Okay, a letter next to it.
It's the number in front of a variable.
Yeah, there we go. Okay. Yeah. And so you're right, it has a variable next to it. Okay, but yeah, it is a number in a term. So we had terms just a second ago. Doesn't matter how many variables we have, but we're going to have one number usually within that term. Okay, so if I said 8 XYZ, 8 is my coefficient. Okay, negative 9 MN. Negative 9 is my coefficient. M and N are the variables. Negative 9 is the coefficient. And we usually put the number in front of the variables. We don't necessarily have to put a multiplication sign in here. This is assumed to be multiplication if we have a number next to two variables, or one variable, however many we have. Okay, we're almost there. Like terms versus unlike terms. We've seen it a couple times today. We've talked about it. If two terms are alike, they have the same variable, same exponent. Coefficient doesn't matter here, okay? But these two terms would be alike because they have the same variable x and they have the same exponent of 2. I could do 3y to the 4th and negative 12y to the 4th. If they have a different letter or a different exponent, they're not alike. You've got to have both. So then if we did some examples of unlike, maybe it's 2x and 6x squared. Okay, they both have an x in them, that's good, but one's got a 2 and one's got an assumed 1 as its exponent right here. Okay, so those are not alike. And it's going to be important to know the difference between those two because can we combine them together versus not? And these two we would not be able to combine together. Okay. Pretty easily, we know something like 3y and 8n are not alike because they're completely different variables. Okay? Even if they both had squareds on them, it's still not alike, right? Got to have the same variable, so the exponent being the same is not enough. Okay? So once again, another thing that I think we can pull in from previous knowledge, but we got to be really careful about that. When and when we cannot combine like terms, because that's the last thing here that we're going to talk about. I'm going to give you a couple of examples here. If we were to combine like terms, and I give you an expression like this. Okay. You can do this however you want to, but like here the x's are alike and the y's are alike. So I kind of like to underline them with different things to say, okay, these two are the same, these two are the same. Sometimes they'll say to use the commutative property here. So like I could flip-flop these two around and I could put the x next to the other x. Do we have to do that? Probably not, okay? We can notice what terms are alike and that helps us to know which ones we're going to combine. If it helps you to move it around, just make sure, like I could rewrite this one as 10x minus x plus 7y plus 6y. Then I know these two are going to stay together, these two are going to stay together, right? So this would become 9x plus 13y, and that would be our answer. That's as far as I can go. Because remember, there's an assumed 1 in front of that x. Okay, one more. This one is a little bit harder. Okay, see if you can simplify and combine like terms here. See if what you can do on this one. Okay, what are we going to start with? Any ideas, any thoughts on where we would begin? Distribute, okay? And here's where you got to be really careful. When I distribute, because there's a negative or a minus sign in front of the 2, when I distribute it, that minus sign is going to distribute with that 2. So this becomes 3h plus k minus 10h minus 6k minus 9 plus 5k. So really got to watch your signs. Okay, and here's why I would say you probably don't have to rearrange everything, because I think it almost takes more time. As long as you can identify, okay, these have h's, these have k's, these are just numbers, then h, and that's it. But when I combine these two together, in front of the 10 is a minus sign, right? So 3h minus 10h would be negative 7h. Okay, and then k's. We got 3 k's in this problem. Different k's. So this would be 1k minus 6k, which would be negative 5. Negative 5 plus 5. What happens to my k's? They're gone, right? They make 0, okay? Do we need to write 0k? That'd be silly, right? There's no reason to write 0k because there's no k's. If I have 0 of something, that means we have nothing. And then the minus 9 is all by itself. And that'd be our answer. Okay? How do we do on that? So-so? Okay. This will be the last assignment then for Chapter 1. I don't think I'll have time to get your quizzes back today. So on Monday, we will review. I will let you correct your quiz in class. We did pretty good on the quizzes, so there's not a ton to correct. So if you want to correct on or in class on Monday, I'll let you do that. So you can kind of get started off on the right foot here. And most of the corrections will be pretty easy to do as well.